Okay, guys. So we will now attempt some basic programs. Okay, some very fundamental programs. So there are two ways you can do in your homes as well as in lab. One is that for writing a C program and for executing it, okay, you can use a cloud-based online compiler. One thing, cloud-based means it's available on internet. There is a site. You have to get into the site. You will get some editor pane where you can write the code, and there will be run button. You run and you get the output. Right? Like for example, let me open just search any possible online compiler. So mostly all the online compilers they support multiple languages, right? Just to make things easy, I will search online C compiler. Okay. So you can see program is also providing, right? This is one side. Then online GDB, online compiler.io, code chef. That's so many, right? Okay. I will just pick any of these. Okay. It doesn't differ much. Okay. Now you see here, this is the editor pane where you write your program. This left side, this left window is your editor pane, right? And here a very basic program is written. Okay? A very basic program is written. Okay. And if you want to give any input, you can give it from here, and whatever the output is, the output will be shown over here, right? Okay. So this whole content you can assume to be in a source code. Okay. And when you do it for your desktop, you will have to save it on your desktop, right? On your machine, right? Desktop means desktop machine, right? Or a laptop, whatever. Okay. So the extension should be .c. But here, because it's online, you do not have to worry of saving it. It is going to automatically take care of it. In fact, it's just a dynamic thing. You keep on changing, and there's no way to keep things persistent unless until you go for the paid subscriptions of these compilers, right? So, like for example, here is the drop down where you can see multiple languages, right? C++, C, Python, Java, and C Sharp, and so on, right? So C is selected over here. Same look and feel you will find in almost every online compilers, right? The first line that you are seeing is hash include and then a less than bracket and a greater than bracket, right? And within that bracket, you will see stdio.h. Okay? This stdio.h is called as the header file. Fine? This is the header file. Now, the header files are those files which we include in our program. They may have certain predefined functions, okay, that we can use in our program, right? So stdio stands for standard input output, okay? That is reading from the keyboard or writing on the console. So all these comes under the standard input output functions. So to perform the standard input output, we need to call certain functions, okay, certain behaviors, okay, from this stdio.h file, right? And the next thing that you see is there is something called as main, okay? Main, correct? As the name indicates, its main means it's something important, right? So we call this main function. We call this main functions, okay? See, in a program, there are two kinds of things. One that represents the data, okay? For example, if you want to add two numbers, then there has to be some storage for storing those two numbers. Like I give the name A for first number, B for second number, and result for the computed output, right? So because I have got A as a container, B as a container, result as a container, A got some value, B got some value, then I will say result is equal to A plus B, right? So A, B and result, all these are part of data representation, right? Somehow they are the containers to hold the data. Yeah. Uh, I think just a second. Good now? ठीक है. So there is some part of the program which represents the data, right? As we just understood, right? And if there is certain computation on the data, so those computations are written in the form of statements, right? Right? Like for example, result is equal to A plus B is a mathematical expression, right? So it is written in a statement. Now the statement should be contained in something called as a function. Okay? Function. Often called as method. And the very general representation, just as compared to data, as I said, is behavior. Behavior. That means a function is something which contains set of instructions to do something. Okay? When someone does something, we call it a function or a method, or in general we call it the behavior part of the program. Okay? So there are two parts of the program in any language whatsoever. One is the data part, the containers that we define. Okay? As of now, I am saying containers, but the right term to use in the programming language is what? I would say fields rather, because fields may contain constant as well as variables, right? So constant is something which doesn't changes over time, like the value of pi, as I said before, 3.14. So it's not going to change throughout the computation or the existence of the program, lifetime of the program, because from the business logic that restricts us. Okay? But the value of A, B, and C, if I want to make that program dynamic, that may take different A and B and compute result on them every time. So that means A and B must vary over time with different values. A and B should have the capacity to get new values over time. So that is why we call them as variable. In general, both constant and variables are called as fields. And they are the data part of the program. Okay? Whereas a function which contains statements to do something, those statements are meant to do something. So such grouping of such statements, right, is called as function. Like you all students are sitting in a room and the room is enclosed, right? Suppose this room is a function and you all are statements. So there could be many statements in one function, right? Okay. Function cannot exist outside, statement cannot exist outside a function. Statement needs to be inside the function. So for example, as I said, main is a function and main is an important function. That's why we give it a name as main. So not only in C language, as soon as you start learning other languages also, you will realize that this main function is the part of almost every language, right? You will encounter this main. This name main itself is that function which is important. And the importance is this is the first entry point of the program. So whatever instructions you give inside the main, those will be executed first. Okay? That means in this program, I can have not just one function, that is the grouping of statements or the behavior. I can have multiple functions. That means multiple behaviors. Okay? But when the program starts, not every function will be entered. Only the main will be entered first. Right? And from main, we can write further instructions to call the other functions. I'm repeating, to call the other functions. Those functions will be called. Okay? Right? Like for example, I call one of you and give some task to do. Okay? He will do the task, return me back the results. Okay? Similarly, these groups of instructions, they could be written into multiple functions. Like, for example, if I have a calculator program to represent a normal calculator, so I can write different functions like add, subtract, multiply, divide. So these will be different functions, and the instructions written inside this function will be different. Inside the add method, it will be for adding maybe two numbers or three numbers. Inside subtraction, it will be for subtracting two number. Okay? We can add even logic that if number A is greater than B, then we will say A minus B. Otherwise, we will say B minus A to return absolute number of the subtraction. So we can keep on altering the logic as per the business or the requirement of the application or the program that we are building. Okay? So those behavior, as I said, are called as functions or methods. Okay? Right? And main is a function, and the function has a body. Like this room has a boundary, right? So that you have a you are enclosed within this body of the room. So similarly, this main function has got a body, and the body is represented by curly braces. So this is a starting curly braces. You see this symbol. Just a second. Okay. So you can differentiate between these two curly braces, right? One is the opening curly braces, the other is the closing curly braces, right? So this indicates the body of the function, just like the walls of the room. Okay? All the statements which are within these two curly braces belong to this main function. Correct? You can identify the function by this parenthesis also. Okay? After main, you can see the parenthesis which is opening and closing, right? So this itself is an indication that it's a function. Okay? It's a function. Correct? That is the behavior part of the program. Then let's say I just want to print something, a message on the screen. Okay? So I will use another function. I said a program may have many functions, right? So I will use another function, printf. Okay? And here, what should I do? Say I want to print some message, hello world. Okay? Is it correct? Fine now? चला के देखिए एक बार. What is this written? We will see later. Don't worry about it. Okay? चलेगा? देखिए. What you got the output? Hello world. Now this printf is a function. ये ऐसा main जैसा नहीं लग रहा है जिसके पास braces हैं. Just that we have passed some message to it. है ना? Like I said, I call one of you and give a file to him. ठीक है? So assume printf is someone whom I have called and I have given this message to him. Now he goes, interacts with the operating system as we have learned in the previous classes, hands over the message somehow or the communication somehow to the operating system. The operating system takes the control of the output devices associated with our in stream, the output stream which is coming, and then this message goes to the output device which is console here. The output device could be printer also, right? Correct? And so you get the output here. So this printf function, but you do not see a printf function I am using this printf function, I am calling this printf function, but I have not declared, or not declared, rather I should say, not defined this printf function, that how it is going to interact with the operating system, right? How it is going to take care of the output on the console and whatsoever, right? We have not defined this. We are just using it. And when we use a function, we say we are calling the function, right? So we have called the function, but we have not defined the function. Why? Because this is a input output level nitty-gritty, that requires operating system in between, right? So the builders of the language already have built such functions like printf to print, and there is another function scanf to read from the keyboard. So input output means two things. Input means reading and output means writing, right? So scanf for reading, printf for writing on the console, right? So such kind of functions are already pre-built by the C language developers, and they have kept such function in this file or this header file stdio.h, standard input output header file. So that means if I am using this printf function, it's not coming from space, it's coming from this header file that we have already included in our program to be used. Okay? So assume header files are the group of certain functions which are meant for specific kind of task to be done. Okay? And we are just using it within our program. Clear? Now, what is the return zero? Because this main function has an int before it. Okay? Suppose, let me give another example. If I would have written a function int add and then int x comma int y, right? And then there is a body of the function, correct? And then I will say int result is equal to 0. Initially it is 0. Okay? Then whatever the value x and y gets, I want to compute it and put the result into the result variable. Okay? Result is equal to a plus b. Correct? Not double equal to, but single equal to, right? A plus b. Right? And then I will say return result. Okay? So looking at this add function, what we understand, just like this printf function requires something to be printed. So I am passing an argument, hello world. Okay? If I want to call this add function, I will call add, say for example 5 comma 8. Now this 5 comma 8 are arguments. Okay? Just like printf requires a string message, this add method requires two numbers, integer numbers, right? So these are called arguments here. But here, while defining the method itself, that is what this method is and what it will do, what are the instructions it contains, okay? I will call this list of integers of x and y, or the two numbers x and y, as the parameters of add function. What I will call? The parameters of the add function. So the place from where I am passing the value or calling the function, the values that I pass, these values are called as arguments. These values are called as arguments. So 5 and 8 are arguments to the add method. Hello world is the argument to the printf method, right? Whereas int x, int y, these are the parameters or the defined containers list which receives these arguments. So 5 will come to x, 8 will come to y. Okay? 5 will come to x, 8 will come to y. Result initially I have defined as 0. Initially result will be initialized with 0. Okay? Result will be initialized with 0, with a value 0. So I make a empty container because I do not want to keep it empty. It doesn't look good to me. So I'm just putting 0 inside it. Okay? Now result is equal to a plus b, then 5 and 8, that becomes 13. 13 will be assigned to the result, and then this result is written back to the caller here, right? So I'm calling from this line. If this is being written over here, I must collect it as well. Okay? I have given a task, a file to a student to do some editing work or to do some correction. He goes, sits for an hour, does the correction. He brings and hand over files to me. So I take it back, right? I take it back. So that means if I am calling this function and this function is calculating the result and this function is returning me with the result, then here the caller, this line number 6, you can see this line number 6, right? This must also collect the result to use it further, right? So let me call int c is equal to this. Now whatever is written back, suppose that is replaced at this call add. Okay? So 13 is replaced here, and on the left hand side of equal to is what? Another container, a variable c with the name c. Okay? So now the result, the value of the result comes to this line number 6, the right hand side, where I have called the function. So that function call assume at the runtime a value is replaced over there. Just assume in mind. Okay? And that value is assigned to this container C. Simple, right? And if I want to do something with that value, what I can do, let me say that I again want to print it on the screen. So I will say printf, right? Printing. And this time what I will do something different. I will say %d, right? Then, comma, I will write the name of the variable. So this %d means it's a placeholder. It's a placeholder that says what I am going to print next is a digit. It's a digit because C contains a numeric value. So the value of C, which is 13, will be printed to the console and the instruction will be sent that it's a digit. Okay? My program understands that. Let's run it and let's see. Oh, so there is a problem. There is some problem. Okay? Yes, we have done a mistake, right? We have done a mistake, so I am getting a compilation error. What does the compiler does? It reads the whole program at once, convert it to the form which machine can understand and execute, right? Machine executable form, right? In Windows, we say the file is converted to .exe file, which is the executable file, right? So the compilation tried to convert it. Okay? And when the compiler tried to convert it, it found a compilation error, that there is a mistake you have done. And it is giving me the mistake. What mistake? It is telling me in function add, that means in add function that you have defined, a undeclared. I do not know what does this a means, because the name of the container is not a. I have given the name of the container as x and y, not a and b, right? So this is a mistake. My mind is somewhere else, right? So I keep giving the examples of a and b. So I typed it here without realizing that while giving the name in the parameter list, I have not used a and b, but rather I have used x and y, right? So I will have to correct this mistake. Either I will have to change this a, x and y to a and b, or I will have to change this a and b to x and y. Both are same thing, right? Correct? Now let's try again. We have rectified, right? Let me run again. I'm pressing the run button. Now you see hello world, and without any space, I got 13, right? The result. Now I wanted it to be in the next line, right? I wanted it to be in the next line because this is very confusing. Hello world and 13, I'm confused, right? So what I will do is where I am printing, I will just after percentage D or even before percentage D, what I can do is I can say backslash n, sorry, slash n, right? And let me run it and let's see. Now you see hello world and 13. So slash n means it's a new line and indicates for new line. Okay. Now you are getting how we write the code. Okay. Simple code, right? And the learning that you are getting in this first programming class will last forever for almost every programming language. Okay. Correct. So do not mistake this class to be another theory class. It's like you have to keep on practicing also. Okay. So at least you are getting something to do in the lab now, right? So let me just copy this program and let me open the WhatsApp group, and right now let me paste this program into the WhatsApp group. So yeah, what is the difference between arguments and parameter, right? So you see here we call the function add, right? Similarly we call the function printf here, right? And we pass some values over here. Now this string value hello world is an argument at this line number 5 that I am passing to this function while calling this function. Okay. Similarly, inside the add function, while calling the add function at line number 6, I am passing the argument 5 and 8. So these are arguments. Okay. Now this argument must land on inside the container with the label x and y. But these containers will be created at the runtime when the programs run. As of now, when it's a passive code, it's not in the memory. The x and y are not occupying any space. It's just a passive code unless and until I try to run it, right? And when I try to compile it, automatically after the compilation, when the compilation is successful, there are no compilation error, the program is run or executed, right? So x and y will come into picture at that time, and they will carry the values 5 and 8, 5 for x and 8 for y. But while we give the specification of add or the blueprint of add, that whatever value it is expecting, on what level of container it will go, what will be the nature of container, like int, which is a numeric value, right? Correct. And what computation it is going to do, where it will put the computation, and then how it is going to return, right? So all this specification is defined inside this body of, or the declaration in the body of this add function. So while defining this list, that for 5 I have a container with the label x that will be created at the runtime, and for 8 I will have a container y that will be created again at the runtime. So this specifications that will collect the arguments while defining the methods are called as parameter. So here I will call this 5 and 8 as argument, and int and int. I will even not be careful in saying int x or int y. Let's just say two containers of the type int. So int. So this add function has two parameters of the type int. That is two whole numbers, right? So here I will call it a parameter list. and everything inside the parameter is a parameter. Got the difference? Parameter provides the specification of the label of the containers that will be created at the runtime, okay, to hold the arguments. So it's nothing more than a blueprint or a specification. Okay. Actually, it's the same thing. The value 5 is going to land into x, the value 8 is going to land into y. Technically, we call at this line number 6, 5 and 8 as argument, and here int as parameters. Got the point? Just to distinguish between these two things which are happening at different instances. Right? Satisfied or not, Henry? Got it? Okay. If you have any doubt, you can just ask again. Okay? Let me pass this to your WhatsApp group. So this is the first program I will expect you to run. Okay? And now did you realize what this return is there? The return statement basically instruct the runtime, which is actually executing the program at the runtime, to return back the result to the caller. Like the caller of this add method is line number 6, right? So here we are calling, right? So result is a computation, which is a numeric whole number, and so this will be returned to the place from where it is called. As I said, there could be a number of functions, but the program enters into the execution mode from the main functions only. So the control comes to the main function. If I need to call some other function like the add function, I will add a call over here. It will do its task, return me the result, and the result I need to collect, and then I can do whatever I want to do with the result. I can use it another expression, or I can just print it, whatever I like. Correct? So this return statement basically makes sure that you are returning something, and whatever is being returned just before the name of the function, like add function is there, just before I have specified int. Like in the parameter list also I have specified that the container with the variable name or the label name x is of integer type, which is a whole number. The container with the label y, which is going to hold the second argument 8, is again of the whole number or integer type, right? So the computation is also going to be a whole number. If there would have been even a single argument or a parameter which has fractional part to it, the whole result would have changed to fractional part, right? But because both are whole numbers, so the result is also a whole number. So this result must match the promise that okay, this add method is going to return an integer or a whole number value, not a fraction, not a character, not a string. Got that? So this is the promise. This is what we call as a return type. What we call it as? Return type. So like we have got this parameter type, int for x, int for y. Similarly, we have got a return type for whatever value we are going to return, and we are returning the result, right? So that is also going to be integer or a whole number. So this is the promise we have made, and we should make sure that we should not violate this promise. I cannot return a value, say 7.5 over here. Let me try. Let's say what happens. Let's say now this value is returned, this return statement is returning not result but a fractional part, right? Guess what will happen? Some problem should happen, right? Let's see. What happened? 5 is truncated. Spillover. 5 is truncated, right? Correct? So in certain situation, you will see the truncation, that is spillover, the extra part which the promise container could not contain. The promise container is int. So the result will be packed in a form of a package which can only contain numeric value whole numbers. And when you try to fit a fractional part to it, if you just discard the fractional part, correct? So you get the result as 7. What if I try to return a character instead? C. Instead, let me say a character. This is how we represent a character with a single quote. Okay? So A is a character. Now what? Let's see. $97. Just ASCII code. The ASCII code of A is 97. You can just open your phone and search the ASCII ASCII code, ASCII code or ASCII value of small a. You will see 97. So it's a form of conversion. It's a form of conversion. Even though it's a character, I am getting back the result in a numeric representation of that character from the ASCII table. ASCII. Just verify, is it 97 or something else? 97 small a. For capital A, what it is? 65. So that means 97 minus how many 32 characters we have got in English vocabulary? 26. So I think it should be 97 minus 26 something. Is it correct? $91. So maybe you can just explore the ASCII table. Just look at, maybe there could be some other characters, or maybe numeric 0 to 9 may be there. Those 10 digits may be included in between. Okay. Okay, got it? Got the idea? Great. तो इसको भी मैं पेश कर दूं एक बार. So if you break the promise, what will happen? Break the promise means I have promised I will return an integer type and I am returning a numeric value. Earlier I have promised an integer type, I have written a fractional value. What will happen? If I break the promise, the compiler will betray me. Not the compiler, but the runtime will betray me. Compiler will compile it anyhow, but the runtime will betray me or give me the wrong result. Okay? But it will try to give me something which is relevant, sensible in most of the cases. Sometime you will see blunders also, where it doesn't make sense to give anything relevant. Okay? So try with character value as well as fractional value also. Okay? In the lab. Okay? Try returning fractional value. Fractional value क्या बोलते हैं? We call it float. We call the fractional value as floating value, right? Because the numbers after the digit, they can keep floating to any digits, right? Try returning fractional value, okay? Instead of whole number as we did for character A. Okay? So you will try these both examples in the lab. Got it? So similarly, main has got a return type int, right? And I do not see any reason to return a 0. 0 seems a dummy value, right? Because we have not done any computation to come out to this 0, right? We are just returning 0. Why? Because the runtime, or which the part of C environment, which is actually in control of running this program, needs some kind of indication that whether your program has successfully done whatever it is meant to be, or whether it has failed to do something, right? So the program could fail by two ways. One is I do a mistake and I get a compilation error. Okay? That will be the syntax error, right? The other mistake could be I have some type of computation to be done, and within that logic that I wrote, the code I wrote, I did something that makes my or that violates my business understanding. What I thought is not correct. The way I thought is not correct. Okay? And then the error that I got is something which comes at the runtime, something abrupt, right? And somehow I cross check to know that there is an error. Then in that case, I will return a negative value, say -1, -5, anything. So 0 or a positive value is an indication to the runtime that the program was successful. It has done what it is meant to be, right? And a negative value typically means that there was something happened which was wrong, although the program executed. The program was compiled successfully. At the runtime, something gone wrong. While doing the task, something gone wrong. Like for example, I'm just giving a very generic example as of now. I will show this kind of example when times come. So, like for example, for this guy, I handed over the file as I just before, and I asked him to do all the spelling mistakes. He went back and started doing the spelling mistakes. He was sipping his coffee along with. Somehow, hand slipped and the coffee spilled over on the file. The file got destroyed. Now that's happened at the runtime, right? That was not expected somehow. So this is just I'm trying to relate. Don't take it, literally. It's just a thing to relate. So it happens at the runtime. So when he came back to me, he told me, "Sir, I failed because of this reason," and he returned me a negative value as an indication of it. Got that? Okay. So we always return a zero value because we have promised to return something as a whole number, as an indication whether the program or the function main has succeeded in whatever it was meant to do or not. Okay? So a positive, zero or positive means task done. A negative value means any problem. Got the idea? Okay. The other thing that we can do is, instead of trying this online compiler, what we can do is we can install an IDE. IDE stands for Integrated Development Environment. So a piece of software which integrates the compiler. It doesn't contain the compiler of its own most of the time. It's a third-party software, but it integrates the C compiler. Okay? And it uses that C compiler for giving us a development environment that is much easier. This was again an IDE, but a cloud-based IDE. Okay? A very simple cloud-based IDE. And the cloud-based IDE will be having a lot of restrictions. Okay? A very simple restriction is that if you do not have internet connection, you cannot run it. You cannot work, right? Internet is not coming, so you cannot work. So something which is installed on your machine, that is not dependent on the internet connectivity, right? So a very simple and easy to use IDE for you is CodeBlock as of now. Okay? When you start learning some other languages, maybe the teacher could introduce you to a better advanced IDEs, and then you will see using them is far better and far helpful. But as of now, just to not overwhelm you with a lot of options and a lot of things and techniques that the IDE provides, right? We will go with a simple IDE. The lab which is on the first floor, there also we have got the installation done of the code blocks, right? So you will find this code block. So all you have to do is search, download code blocks in your browser, and then you will land to the page where you can download code blocks, okay, for your machine. If it's a window machine, you will have to download for Windows machine. If it's a Linux or Mac machine, appropriately you will download it, okay. So I assume the students of this generation are, great enough to do installation and everything. I do not need to show them, right? If you get any problem, you can just come with your laptop and we will see, okay. So code block is installed. I'm opening the code block, okay. So this is how you will see the screen to come, that will appear over here. And here you will see something called as workspace. So workspace is a display of the project that you are currently working on, okay. So I can create a new project, or I can open an existing project, right? So uh, let me open an existing project, okay. Purposely I am doing this. So if you have already made a project, okay, so it will open the particular folder. See, the folder is where I have kept C drive, C code demo, C code, C code demo. This is the name of the folder inside the C drive. So here I have kept the project. So when I say open existing project, it will show me this, the two folders, bin and obj, and there is a file which has the icon of code block itself, right? And this is the name of the project. This is the name of the project. So I will just click on it and I will say open. So you see, a structure has been created. This is the name of the project. This is the name of the project. A project may contain many C files. A single C file may contain many functions, right? Agree? Okay. And this sources is the folder which contains all the files that I create. So I said that whatever code that I write must go inside a file. I cannot see that file in a cloud environment because cloud is maintaining for us. Okay. I cannot even see the compiled file which will be converted to a machine language for that cloud environment because I do not have access to it, its folder, right? But here I have got the access to my folder, it's on my machine. So main.c is the name of the file, the C file, the source code file. This is the source code, right? And okay, I have written something. Let me just get rid of it and paste the same code what we have just seen in the cloud environment, right? And you see, I will try to run the same program now in code blocks, right? Let me say Control S to save it, Control S to save it, Control plus S to save it, okay? And then you see this button, right? Run. This is the run button. I am going to run it over here. Okay. Somehow the earlier program that I have written is giving the output and it has not taken the new changes that I have written because the code is not compiled. Sometime in this kind of IDEs, you will get the problem. So to fix it, I will just go build and run. So build means build will contain everything like compilation and linking and the loading that the box I said you as an assignment, everything that will be done inside it, and then it will subsequently run, executed, right? So I say build and run. Uh, it says in function main there is a problem. The variable result set but not used. Okay. See, I have written a character a, right? Uh, the result variable is not used. I have calculated the value and put in the result. The cloud environment did not uh, uh, try to be that clever and let me know, but rather this is trying to be understanding that okay, if you have got this result, it must be used somewhere, right? So I am trying to return result, right? So I am returning result. Let me save it. Let's again go for build and run. Implicit declaration, what is that? Hmm? Actually, I have installed this code block, but I have not tried it. How, Okay, let's do one thing. Let's just forget. I will just try to print hello world as of now, right? Let this function be there. Even I will get rid of just to make sure that it's not some other problem. Let me just figure it out. Let's see. Okay, I will have to check what's the problem because I have installed it, but I have not tried to run it. So let's see what's the problem. Anyways, for the printf, it is doing hello world, right? So now you have program written over here in the source code, right? I will not waste to dig into the matter what was there. We will try to figure it out. Okay. So now what I can expect is I can go to the this project folder and I can physically see this file, right? So let me go to the folder inside this C drive. This is the folder, and here I have kept demo is the name of the project, right? So main.c is here, right? And if I go to the bin debug, see demo.exe is being created. So if I try to run it, it's just giving the output and going back. So we have ways to let it stop and wait until I press a key, and we will see it in the next class. Okay. But this is the exe file that I was talking about. That once we have done the compilation, the machine dependent compiled file is created, right? So compiled file is created over here, right? But for the cloud version, the online compiler, we were not able to see either the source code in a file, in a separate file. We can't download that file, or we do not have the provisions to see where the binary is going to be stored. That is, the compiled file is going to be stored because the compiler reads the whole code and compiled into a machine readable form which the processor can run in one go, right? So here we can see that, right? And what we have discussed, that in the case of an interpreter, what happens? Line by line. So that means we cannot expect in the case of an interpreter to any intermediate such compiled file to be generated, right? For example, for that purpose only I have created one small HTML file in the same folder. Just let me open it. See, you see there is a HTML file, right? HTML file is there. Let me open the HTML file. I think everyone must be familiar with the HTML, hypertext markup language. So you see it's a Tang language, right? I have printed a few headers. There are 6 headers in total, H1 to H6. H1 is, I think, the largest size, and H6 is the smallest size. So for every text like HTML is interpreted, it's in the largest size H1, and then the style. A style means I have given it some styling like color is equal to dark blue, so this will be printed dark blue. Then for the browser reads this file line by line, this message will come on the screen with color is equal to green, but in a smaller text than the first one, and so on. Okay. So whatever color is there and whatever the size is there, accordingly the messages will be printed. Now HTML is an interpreted language. That means The interpreter, and where is the interpreter? It's embedded within the browser. Whatever browser you are using, whether you are using Chrome or you are using Internet Explorer or any other browser whatsoever. Okay? So many browsers are there, right? So whatever browsers are there, Edge maybe. So for every browser, there is an interpreter which reads line by line and displays the impact hand in hand at the runtime, right? So let me just run it. Uh, if I try to open this browser, let me say I just say open. Let's say Comet. Okay. See the size H1 to H6 and the color whatever we have given in the style. Now, if I want to make any changes in my C program, which I want to do here in my installed version of the application, not online, so I will have to make the changes, write a new statement, and then go through the build process to compile again. And then a new exe file will be created which will replace the old exe file, right? Okay, because compiler does everything at once and create a new file. In the case of HTML, if I make any changes, that doesn't needs a compilation. Only that changes will be interpreted right then when it is executed by the browser, and the result is changed. So even this browser is still open. I'm not going to close it. The browser is open. What I will do, I will just open in Notepad, right? So the color for the first style was dark blue earlier. Let me change it to say red, correct? And let me save it here in the file, in the source code itself. I will not say build or compile or whatever, what I had to do in the code block, right, for C programming language, because C is a compiled programming language and HTML is an interpreted programming language. Okay? So I will just go to the browser, I will refresh the browser, and you will see the changes instantly, right? So there is no compilation in between, only the interpretation is there, right? If I make a mistake, for example, let me say color is, I did some garbage thing. Control S, save the file. Let me refresh it. It has taken a default value. That means it has not given me a compilation error that the value that you are giving to me is not right value. It has just not done the task properly. Okay? So I hope uh, this has clarified the task of interpreter and the compiler. Okay? So with this, I believe we can go with the first lab and then we will continue again. Okay?